Good evening, everyone. My name is Aditya Sharma, and this is Power Plant System Engineering course, as we all know, being conducted under the NPTEL program, National Program on Technology Enhanced Learning, and it is under this program that this course is being conducted by Department of Mechanical Engineering, IIT Guwahati, right? And we are into the 11th week of this course, which is Power Plant System Engineering. And the theme for this uh, week's discussion and content again is hydro and renewable energy power generation system. So, in the previous week's content, we saw hydropower systems and wind energy. Okay, so discussion was focused mainly on these two systems. Okay, then in this week's content, we will be basically focusing on waves, ocean waves, and your tidal energy. Okay. The instructor for the course is Professor Niranjan Sahu from Department of Mechanical Engineering, IIT Guwahati, and I'm a research scholar here at IIT Guwahati only. So we shall start in another few minutes, couple of minutes. Okay. Till then, let's wait. Okay, so we can start with today's session. Okay, so let's see first of all the contents of today's session. So we have three lectures in week 11. Lecture number 29, 30, and 31. So 29th lecture is based on energy from oceans. Lecture 30 is the continuation of the previous lecture. Okay, then the next lecture is on geothermal energy. So all these, first of all, are renewable sources of energy. Okay, renewable energy sources, which means they can be renewed. Yes, so geothermal energy. Okay, so this is topics of lecture number 29. As we discuss the topics briefly, then we'll go on to questions of this lecture, and the same way for other two lectures. We will proceed. Okay. All right. So topics, four major topics are concept of ocean wave energy, then ocean temperature difference, then open cycle ocean temperature energy conversion, closed cycle OTEC. Okay. So the concept, first topic is concept of ocean wave energy. Right. In this, the second term, if you see, the other half term is wave. So this wave energy has not been discussed, I believe, in this. Yes, this has not been discussed in this lecture, but in the next lecture. So we will say it there only. Okay. Then in this lecture, the energy that we are discussing from ocean is this by means of temperature difference. Okay. So what is this temperature difference? So because of solar insolation, yes, because of solar insolation, your water, the ocean water gets heated, right? And this is basically because of radiation, right? Heat transfer is through radiations. Then to some extent, this radiation penetrates the water, right? Beyond water surface and heats the water, ocean water. But beyond certain depth, okay, from the surface, water surface beyond some depth, this radiation is not able to heat water, right? And, and so below that level, the water remains cold. So the surface water is at some warm temperature, and then beneath it is your cold water, right? So this is the temperature difference that is being discussed in this lecture, and how we harness this, right? How we, or say, use it. Okay. So this was your concept of. So this was briefly discussed, right? And the wave energy is because of your between two celestial bodies. One is Earth, right? And the other one is Moon. Okay. So this gravitational forces between your Earth and Moon. So this is the cause of your tidal energy. Okay. So there are instances when your moon is closer to Earth, then there are instances when the moon is distant from the Earth. Okay, so this leads to difference in gravitational forces between these two celestial bodies, and this impacts the water that is there in oceans, which leads to tides and thus tidal energy. Then next topic here is, if you see, ocean temperature difference. So I have briefly discussed that how the differences in temperature develop. Okay, so the law that governs this temperature difference, right? That is Lambert's law of absorption. Okay, which basically says that where I of y is, so this is your Lambert's law of absorption. Absorption of what? Solar radiation. Okay, and what is y? Y basically is your If this is your water surface, so y is in this direction. Okay, so let's say this is your water surface. Okay, water surface. So at some depth y, if you want to know the intensity of radiation, so we can use this law, right? So the cycles that we use, okay, so cycles that we use to use the temperature differences, ocean temperature differences for energy conversion are: one is your open cycle, one is your closed cycle. Now, what is open cycle and closed cycle? What do they mean? So, open cycle basically is when your working fluid will circulate, keep circulating in the cycle, the same working fluid. Sorry, that is closed cycle. Okay. And what is open cycle? Open cycle is the one where if the fluid enters in the cycle, right, the same working fluid won't be used in every cycle, right? So that is basically your open cycle and closed cycle, right? They have been given names also. So open cycle is your Claude cycle, right? Claude cycle, and this is your Anderson cycle. So from your open cycle, what are the major takeaways? So OTC basically is ocean temperature energy conversion. Okay. So if you have gone through the lectures, what are the major takeaways? In the open cycle OTC, OTEC systems, what? First is your low pressure steam is used. Low pressure steam with high specific volume. If you compare it with the conventional steam power plants that we discussed in vapor power systems. Okay. Other than this, you need a very large ocean water mass and volume flow rate is used. Okay. And if you wish to see its TS diagram, so you can refer to the lecture that will be given in the description. Okay. Lecture number 29. Then in your closed cycle OTC system, please remember we are just touching upon the topics of lecture number 29. Then, what is your closed cycle OTC system? What are the takeaways from this topic? One is the working fluid. So in your open cycle OTC system, you were using the same water that you were taking from your source, okay, or from the ocean, right? And then to uh, for cooling purpose, you were taking the water that was at depths, right? Then here, what is the working fluid? Working fluid here is not used as water. Okay, water is not used as a working fluid here. So in case ammonia or propane or freon is used as a working fluid, right? And these and in this system, we use heat exchangers to exchange heat from your hot water of ocean with your working fluid, right? Then here the turbines that are to be used are smaller in comparison to your open cycle system. Okay, so this is your closed cycle OTEC system. Then the questions based on this lecture's content. So question one says that tides are primarily caused due to the net effect of gravitational forces of lunar and solar cycle on oceans in Earth's surfaces. So this is clearly true. Okay, just for your revision. Next question is the solar energy absorption by water takes place according to dash law of absorption. Four options are given. So I have discussed here. This is Lambert's law of absorption. Okay. So A option is the right option. Then moving on to the next question. Yes, please answer this. So if you understand the latitudes and how they are defined, this is not a big deal. So how are the latitudes defined? Let's say this is your Earth. Okay. Let's say somewhere here you have your equator. Okay. I'll draw it circular. In front, I'll draw it solid, and in the back, through dashed lines. So your Earth, to get the to define some location on your Earth, we have divided it into longitudes and your latitudes. Okay. So if this is your north and this is your south, so these lines, these circular lines, if we consider Earth as a sphere. Okay. So another line I'll draw. This way. This way. This way. Okay. So this is your equator. Equator is your 0 degrees. Okay. Let me draw one more here. So this is your, let's say, Tropic of Cancer, and this is your Tropic of Capricorn. Now you must be knowing that the seasons. Why do seasons take place? Summer and winter seasons. So this basically is because this your axis is basically tilted. This axis basically of Earth is tilted, right? And because of this tilt and your Earth revolving around the sun, right, in the solar system. Because of this, there are times when your Earth is, your sun is at the Tropic of Cancer, okay, and there are times when your Earth is at the Tropic of Capricorn, okay, because of this tilt, and the Earth oscillates between, or the sun oscillates between Tropic of Cancer and Capricorn, or it seems to us, okay, that it's oscillating between Tropic of Cancer and Capricorn, and this basically causes your seasons. Yes, when the sun is at Tropic of Cancer, there is summers in your northern hemisphere. When it's at Tropic of Capricorn, then there is summers in your southern hemisphere, right? So in Australia, you'll see when there are summers in Australia, there are winters in India. When there are summers in India, there are winters in Australia. So this way, right? So this is basically the region where you get the maximum insolation of your sun, and the poles are those regions where you get the minimum insolation, solar insolation. Understood? Then, then if you see the options, so what should be the most suited latitude? So it obviously will be equator, right? Out of four options, if you see, the maximum insolation your equator will have. Okay, so 90-degree north, 90-degree south, 45-degree north. So this is your basically 90-degree north, and this is your 90 degrees south. Latitude basically is drawn by considering that we are at the center of your, we are at the center of your earth. From there we are drawing lines on these circles, okay. So this angle basically is your latitude. I hope now it is understood what a latitude is. So as you go this way, this theta will increase, and at the top, at the poles, this will be 90 degrees. This is how we define latitudes. So this was your question number 3. Which of the following is not used as a working fluid in the closed cycle OTC systems? Propane, water, ammonia, freon. Freon is used, ammonia is used, propane is used. Water is not used. So that is the correct option. Okay, so this was it about your lecture number 29, right? Then we have lecture number 30. So energy from oceans, part 2. Here we will be discussing waves, ocean waves and your tidal energy. So these are the topics. Let's see one by one. Ocean waves. So first of all, ocean waves have potential in the form of potential energy and kinetic energy, right? So wave motion basically is this motion. Okay. So when the surface water gets lifted up because of wave, so this is your crest, this is your trough. So because of wave motion, your water gets lifted up at the crest. This gives rise to potential energy, right? But then also there is kinetic energy present because of this wave motion. Okay. And in your if your wave is sinusoidal in nature, in that case these two energies are equal. So there are parameters related to wave motion that we must be very clear about. So one is your wavelength, then is your amplitude, then is your period, then is your wave propagation velocity. So what is lambda? Lambda is basically wavelength. Okay. So when we have seen one crest and one trough, in that case, one wave cycle has completed. Okay. And this length from 0 to A is your wavelength, length of the wave. Okay. What is your amplitude? Amplitude basically is this. 0 to B is your amplitude. O to B is your amplitude. O to A is your wavelength. Then the time taken. Okay. And then it has to reach at point A. So the time it will take to reach there. That basically is the period, wave period. Okay. And what is wave propagation velocity? Wave propagation velocity basically is your, this is if lambda, if this is amplitude A, this is period tau, then wave propagation velocity c is c by tau. So this is your wave propagation velocity. Okay. So these are fundamentals of your wave motion. Then if you have to model your wave motion, okay, so it can be done this way. Now what is basically this expression says? So this expression basically, sorry, x has to be written. Yes. Says that let's say we have some location x. Okay. So this basically is from your 0 to some point in the x-axis. X. You need to find the displacement of the water particle. Okay. That is why. So if you see this, so this basically is, so this is one instance. It's not necessary that the wave has to be in this form only. Okay. So this basically for the timing I am writing as well. So based on your x and based on the time that has passed, you can find out this displacement of the particle. And what is A? A basically is your amplitude. So I have already written it as amplitude. Okay. Just give me a second. Yes. So this is your basically wave. Okay. Wave motion. Then one important point also is the path, path of water particles. So the water particles that are indulged in your wave motion. Okay. So let's say this is your wave motion, this is your water particle, and this wave is moving from here. So what will happen to this? Ideally, this should go like this, right? Right. But what happens to water particle? It basically follows an elliptical path as the wave passes through it, right? So for this elliptical path, we have horizontal semi-axis that is defined this way. A, sorry, cos of h okay. So A is your amplitude, this is your eta is your distance from the bottom, h is your water depth, and m is from here some ratio is there. Okay, either this ratio or this ratio is called m. So this is your horizontal semi-axis. Then is your vertical semi-axis, beta. This basically is your wave motion. Okay, and the path that is followed by your water particle. So if we dwell more deeper into wave motion, we can figure out how all these expressions came. Yes. Then is your, so this was your wave motion. Then is your energy and power from waves. So, so I have told that if it's sinusoidal, then they both are same. And what is the value? So you're talking about ocean waves. G. Rho is density, A is what? Amplitude, lambda is your wavelength, L is the width of your wave. So wave will have some width, okay, perpendicular to the direction of motion. So this width will be, so if wave is moving in this direction, okay, it will obviously have some width on the water surface. So this is that, L is that width, G is your acceleration due to gravity. So these are the potential energies and kinetic energies related to two energies, potential energy and kinetic energy related to your wave motion. Okay, then there are devices to discuss that are used to harness this energy. Okay, one is where you pressurize air, where we use, and one is where you use pressurized water. So the concept is same. You will pressurize, you will compress air, and this compressed air will be passed through a turbine. So this turbine will rotate, and it will be eventually connected to a generator. This generator will produce electricity. Same is with your pressurized water. Okay, so the pressurized water will pass through water turbines and through water turbines to generators, electricity generators, and this way it will work. Then is your tidal energy. So what happens in your tidal energy? So this basically is gravitational force. Okay. Then lunar cycle. Then is your spring and neap. So this is something like this. Right? So it goes like this. The zigzag basically is highs and lows with respect to your tides. So this is your new moon location. Okay, this is your full moon location. This is again your new moon location. So now what happens is, yes. So these consecutive two peaks, if you see, right? This basically is 12 hours 25 minutes of distance. Why? Because let's say this is your high tide. Okay, point A is your high tide, then point B is your low tide, right? Then again point A dash is your, so let's call this A1 and B1. Then we call it A2 and B2. Okay, A2 and B2. So from A1 to B1, A1 to B1, how much time does it take? 6 hours, 12.5 minutes. Okay. From B1 to A2, how much time does it take? It takes 6 hours, 12.5 minutes. All right. So this basically is the movement of tide, right? And then the highest tide that you will see, the highest tide that you will see is during your new moon and during your full moon, right? That are called the spring, right? And neap will be when you are in your, this is your third quarter, this is your third quarter, and this is your first, this is your first quarter, first quarter. So in 24 hour 15 minutes, right, you will have two high tides and two low tides, right? And one high tide and one low tide in combination is used to harness is its tidal energy, because when high tide comes, your dam gets filled, right? Now comes the dam into picture, right? So this is your low tide, this is your high tide, this is your dam. At your low tide, this will get fulfilled. This will get filled. Tide will come this way. Okay. At high tide, this dam will get filled, and at low tide, this the water will recede, right? And the water will be at the level of your low tide. In that case, you release the water from your dam and harness its potential energy. Okay. So that basically is high tide and low tide. So A1 to B1 is high tide to low tide. So it takes 6 hours, 12.5 minutes, right? Then again, low tide to, you'll have to again go to high tide. That will again take 6 hours, 12.5 minutes to again fill your dam. So in total, if you see, the one tidal cycle takes place in 12.5 minutes. Sorry, 6 hours, 12 hours and 25 minutes. Okay. So in 24 hours, 50 minutes, you can have this two sets of tidal cycles where you can harness the tidal energy, right? So this was it about tidal energy. So next we will see the questions based on this lecture. Before that, we will take a short 5 minutes break and then we will continue with our session. Okay, so let's continue with the session. Question number five: in an ocean wave, the path of water particle participating in the plane of wave propagation is elliptical, hyperbolic, straight, parabolic. So I have discussed it. This is parabolic, and the horizontal and vertical semi-axis we can also calculate. Okay, for this elliptical path. The energy in wave motion of oceans is harnessed in the form of compressed air using dash-based device. Four options have been given. So whether this is dynamic pressure based, static pressure based, buoyancy based, or friction based. So in your wave motion, when the wave is at crest, you'll have water getting lifted. At trough, it will be at its lowest. So this behavior of wave or the water particles participating in the wave is used to compress your air. Okay, so what we use is we use some kind of float. Okay, because of when there is crest, this float will get lifted up because of buoyancy. Okay, I hope you know what is buoyancy. And when there is trough, this will again come down. Okay, so this motion basically is used to compress your air. Okay, somehow, and then this compressed air is given to some turbine. From there you get your electricity. Okay, so the correct answer to this question is option number C. I hope you guys got this. Then now if you see question number 7, it says that which of the following statements is correct. Moon rotates around the earth in every 24 or 15 minutes. The tidal range is defined as, yes. So the moon appears to rotate. If you, that would have been correct. But if you say moon rotates around the earth, that will not be a correct statement. Okay. Then the second statement is the tidal range is defined as the difference in water elevation at high tide and water elevation at low tide. So this is correct statement. Third statement is in a single pool tidal system, the power is generated during each tidal period of 24 hours 50 minutes. So that is not true, right? So between one high tide and one low tide, we have 12 hours and 25 minutes, right? But then again, for another cycle, you will have to again get to high tide. So it will again take 6 hours 25 minutes to reach the high tide. So in total, it becomes 12 hours and 25 minutes, right? So in that case, second and third, first and third options are incorrect, right? So in the options, I had not given any such option. So I've added in D option one also. So in that case, these two statements are incorrect. Okay. So this was it about question number 7. All right. Then moving on to next questions. An ocean wave 3 meter long and wave period of this occurs at water surface. This is your lambda, this is your tau. Depth of the wave is 185 meters. Depth of the wave basically is your amplitude. Or height, total height between your crest and trough. Then acceleration due to gravity is given as 9.81 and the density of water is given as 1038 kg per meter cube. Then questions have been asked on based on this information. In that case, this information I believe also is there is something there in this information also that I need to revisit. Okay. So this I'll revisit and then again explain in the next session. All right, so we'll move on to this question. So we need to find out the wave velocity in meter per second. So how we will find? The things we have been given is this has been given as 8.5 period. Height has been given as this. G has been given as 9.8 meter per second square. Density has been given as 1038 kg per meter cube. Okay. Yes. So in that case, 3 meters is the total length, right? So it will be this. Then A is 1.5 meters. Now wavelength, that was the 3 meter was the length of the wave, not the wavelength. So if you need to find out the wavelength, how can we find out? From this formula. So if you calculate this will come out to be this. Okay. And the wave velocity will be lambda by tau. That is, so this, if you calculate, this will come out to be 13.26 meter per second. So this basically is your wave velocity. Okay. Then power density for the wave is. So how we can calculate the power density? First we will calculate the energy density and then multiply it with frequency. So question, solution. Question number 8. Question number 9. Energy density is, sorry, half of rho A square G. What is rho? 1038, 1.5 square to 9.81. Now if you calculate this, this is 11455.62 joule per meter square. So this is your energy density. Then power density you have to calculate. It is this E by A dot F. What is F? F basically is 1 by tau. So this will be 11455.62 into 1 by 8.5. And if you calculate this, this will be this. So now if you want to convert it into kilowatts, then it will be 1.34. Dividing it with 1000. So this was it about your lecture number 30. Then is your lecture number 31. So this lecture is on geothermal energy, origin of geothermal energy, types of geothermal energy, then vapor dominated geothermal energy and liquid dominated geothermal energy. So let's see these topics. Origin of geothermal energy. So what is the source of geothermal energy? Basically the innermost layers of earth, they have molten magma, right? So this molten magma, when comes in contact with your somehow water, okay, so this water gets heated and this energy can be used in your power plant, okay. So this is your geothermal energy. Then your types of geothermal steams. So there are two types. One is your magmatic, meteoritic. So magmatic basically is when your magma is coming in contact with your water, and meteoritic is when the rocks. So magma is coming in contact with your rock. So your rock gets heated, and this rock is coming in contact with your water. So this water gets heated. So this is meteoritic. Okay. So then there are two other topics: vapor dominated geothermal system. Okay. Then is your liquid dominated geothermal system. So in your liquid dominated, you have two types of systems. One is your steam system, then is your binary cycle system. right? So in your vapor dominated geothermal system, you basically take help of throttling. So you have steam and you throttle it, okay? And eventually then after throttling, you expand it in a turbine. And in your liquid dominated geothermal system, you have your hot water from your geothermal source, okay? Then again here you use throttling, and after throttling you use a flash separator to separate the steam from your liquid, okay, liquid form of water, right? Then in your binary cycle system, what you do is you use organic working fluid, okay? Here you use organic working fluid. So this is your binary cycle system. Then the questions. In liquid dominated geothermal systems, organic working fluids are used in a. So the answer to this question is option B. So in your binary cycle system, you use organic working fluids, right? So in your flash steam system, you use your water or working fluid from your well only, right? From where you are getting hot water or steam, right? And eventually steam. Then we can conclude, I believe. Let me check if some. Okay, so then we can conclude it. So there were three lectures. First two lectures were on ocean, oceans, thermal energy, and then wave energy. Okay, and the third, last lecture, 31st lecture was on geothermal energy. Geothermal energy basically is from magma, the hot interior of our Earth, how that takes part in heating water, right? Heat underground water or heating the rocks, right? And that heated rock we use to heat water and use in our vapor power cycle. So that is geothermal energy. And in your wave energy, we have seen that the thermal differences, temperature differences in the ocean water because of solar insolation. Okay, and the Lambert's law that says that how the solar insolation or radiation intensity decreases as we go deeper from this water surface. So this creates a temperature difference, and this temperature difference we use in our vapor power system. And in your wave system, the wave has potential energy and kinetic energy. Okay, so we use this wave energy to compress air or to pressurize water, and then these are sent to turbines, and through turbines we get our energy, right? So this is about this week's content, right? I hope it was a this session was a learning experience, and we shall again meet in the last week's session. The session related to your last week's content. So we will have this session in the next Tuesday at the same time, meaning 6 to 8 p.m. Till then, goodbye and thank you for watching.